Partial fractions. This is one of the beginning chapters of A2 mathematics, pure maths. Relatively easy marks. So once you get the hang of this chapter, you'll be happy seeing this in your paper, hopefully. Once you get the hang of it, it's not hard. I'm telling you, these are one of the easy chapters of maths. So the act of partial fractions, what we do in this chapter is that we take a larger fraction, like say a by b, and we convert it into smaller fractions like c by d plus e by f. Now, that's what we're going to be doing in this entire chapter. We're going to be taking a larger fraction and we're going to be decomposing it into smaller fractions that when you add them will still give you this result. For example, let's say 2 by 3 plus 1 by 2. Put this in your calculator, you should get 7 by 6, right? I'm not putting this on my calculator, so if I'm wrong, then I'm not bad. But if I think it should be 7 by 6. So 7 by 6, when represented in partial fractions, is 2 by 3 plus 1 by 2. So this fraction, its partial fractions are 2 by 3 and 1 by 2. So in this chapter, we won't be so lucky as to have fractions that don't have even a slight mention of x in them. So, but we have to work with the fractions that contain variables. How are we going to do that? I'll make a question up right now and I'll teach you the method. When you get the hang of it, you just keep applying it and it won't get it. Just trust me, it's not hard. I'm gonna repeat that throughout this entire video. It's not hard. Because when you think maths is hard, that's when it is hard. Just assume it to be easy and things will just come to you. Amazing advice. Say 12x plus 3, x plus 2, x minus 3. Now follow this method to the T. I'm going to be explaining how this works as well. So as we said before, 7 by 6 when represented in its partials is 2 by 3 plus 1 by 2. Now since it's x, and also we're dealing with this fraction for the first time, we don't know what the partials are. So we replace the partials with, but we do know what the denominator is. That's very interesting. Because you can see 3, oh, my bad. You can see 3 times 2 gives you 6. So we can say 2 equals to 2 by 3 plus 1 by 2. See, now 3 by 2, 1, and this will give you 2 by 3 plus 1 by 2. Are you seeing the similarity here? Look at the similarity here. We'll apply the same thing when we're working with variables. So a, because we don't know this value. This value we just do not know. This value you have to find out, but we do know what the denominator is going to be. So denominator here is going to be x plus 2, like what we did over here. And guess the other one. It's going to be b over x minus 3. So you can see that partial fractions here will share denominators. It's just here they're multiplying. Here they are in a different fraction. Similarly as to how we find LCM. Remember in say like the 10th grade we used to find out LCMs of fractions that contain x. Because we don't know the exact value of x. So we would just multiply them together. Right, say 2 by 2x plus 3 by 4x squared. So one second. I'll pick a better example. That's not a good example. My bad. 2 over x minus 3, say, let's use that one, plus 4x minus 2. So there's no way of finding out the LCM of these fractions together. It's quite difficult finding the LCM. Not even difficult. It's like the only method we find the LCM is when we multiply those together. And where else do we take the LCM? When we add fractions together, right? So try understanding why we do this method. Why we add a over x plus 2 and b over x minus 3. So now that we've done that, now that we've established that whatever this is equivalent to this plus this. I hope you understand what I did here. So we've understood that. Now what I want to do is I want to move this entire thing and I want to multiply it over here. I want to, because I don't want any denominators in my, when you work with denominators it's hard, so I don't want any denominators here. So I want to move this, both of these brackets, both these brackets over there, and I want to multiply them. So let's go step by step. 12x plus 3, a, x, oh shit, did I write x minus, oh sorry mom, okay. I meant to write x minus 2 here, I accidentally wrote that. X minus 2. Right, so x minus 2 over x minus 2, x minus 3, over x minus 2 plus b, x minus 2, x minus 3, over x minus 3. So you can see I multiplied this with everything here. I multiplied that with everything over there. So you can see x minus 2 and x minus 2 is common, so we cancel that. And we can see x minus 3 and x minus 3 over here is common, so we cancel that. So 12x plus 3. Are you seeing how the jigsaw pieces are just falling into place? How simple this is becoming. X minus 3 plus b, x minus 2. So we simplified it. Now we can say that 12x plus 3 is equal to whatever the hell I wrote over here. So now the best way to solve this is to equate each of these to 0, because we want to find the factors of this equation, right? So the factors here, x minus 3. So let's take that as 0. Let's equate it to 0. So you should get x is equal to 3. So 12. Now I want to plug it to both sides, because whichever value of x you take over here will be equal to whatever value of x you take over here. Why did I do that? It's because I placed an equal sign over here. So whatever value of x I place on both sides, I should still get the same expression. Plus 3 is equal to a. Now 3 minus 3, well, I mean, it's 0. Plus b, 3 minus 2. 36 plus 3 equals to 0, because, you know, a, whatever value of a, when you multiply with 0, you should get, surprise, 0, plus b. So 39 is equal to b. And now let's solve for a. Now to solve for a, we do the same thing. We take this. We equate this to 0. So x minus 2 is equal to 0. And now I want to equate this to 0. Sorry, I want to solve this. So x is equal to 2. I plug that back into my equation. 2 plus 3 is equal to a. Now this won't be equal to 0. This will. So 24, this Apple Pen, man. 24 plus 3 is equal to, this is negative 1, so negative a. 27 equal to negative a, so negative 27. See how simple that was? See how simple that was? That was just it. That was it. That was the entire process. So I want to represent my equation. Let's look over. Now that we have the values of a is equal to negative 27 and b is equal to 39. I want to rewrite my equation now that I've solved it. You know, I'll verify with you right now that my answer is correct. I'll verify with you just to show you that this is not necessary. This is not a necessary step when you're in the exam, but I'm showing you that this method does work. It's not just something I came up with. This method does work. So 12x plus 3, negative 27, x minus 3 plus, what was the value of b again? 39. X minus 2. 12x plus 3 equal to minus 27x plus 27 into 3 is plus 81. I'm so sorry for my bad handwriting. Plus 39x and 39 into 2 minus 78. So let's solve 12x plus 3 minus 27 plus 39. Minus 27 plus 39, you get 12x, and 81 minus 78, you get 3. Hence, I've proved that my solution is correct. Now, you don't need to do this in the exam. You can if you have enough time, like on a rough piece of paper, just to show that your partial fractions is correct. But I recommend not spending too much time on this question type because this is one of the easier question types. You want to spend more time on harder ones like trigonometry, differentiation, complex numbers. That all comes later. Right now, I'm just showing you that this method is true and tested and that it works. So just absorb whatever I did in this lecture, watch it 1 or 2 times. Can't even call it a lecture. But absorb it, watch it 2 or 3 times, just understand what I've done here. And that's the first case. This is the first case. And I'll do the second case and then the third, as like my videos progress. And comment whatever chapter I should do next after this.